Hello everyone, my name is Ashish and welcome to the Xadmin channel. So today we will discuss about a queue in a data structure. And in my last lecture we discussed about the stag, and also there we have seen how we can implement a custom stag with a Java language. So today we will discuss the queue. Also we will discuss the type of queues. Also we will see how we can implement a queue with a Java language, right? So the purpose of this lecture is to make your concept like very clear on the topic of queue in data structure, so that it will help you to crack the interview on the question of the queue. So guys, I will like suggest you to watch this lecture till the end, and also subscribe the channel and hit the like button. So guys, let us start the session. So first we will see the definition of a queue, and then we will try to understand that what is queue. So queue is a linear data structure. So queue is a type of data structure, and it is a linear data structure where the first element is inserted from one end, and and always the element is deleted from the other end. So basically the queue has two end. The first is the rear end, and the second end is called as the front end. So from the rear end we insert the data or the element in a queue, and from the front end we we like take out the data or like delete the data. So that end is known as a front end. So front point to the beginning of the queue, and the rear points to the end of the queue. And the queue follows FIFO principle, that is first in, first out. So FIFO means first in, first out, and the name, and with the name you can understand that first in, first out means that like whatever we insert first will come out first. So according to the FIFO structure, the element inserted first will always be removed first. So in a queue, one end is always used to insert the data, and that process is known as enqueue. So enqueue is a term which is used when we insert a data or the element from one end, and dequeue is a process or a term by which we delete the data or like take out data from the other end. So that is known as dequeue. So basically the queue has two end, the rear end and the front end, and the enqueue is a term or a method or a function by which we insert the data from one end, and dequeue is a process by which we delete the data from the queue from one end. So enqueue and dequeue are the two important functions used in a queue, right? So this is a brief definition about a queue. So here in the diagram you can see, and let's say that queue is an array, and here you can see it has two end. The first end is known as the front end, and the last end is known as a rear end. So when we insert the data, so we insert the data from the rear end, and the inserting data is known as enqueue. So here by seeing the array, you can say that the first element which was inserted is 9, after that element 5, after that 7, and then 3. And now let's say that we want to enqueue or insert another data, that is 4, then we have to insert that data from the rear end, and it will come behind the 3. As the queue follows the FIFO, means first in, first out, it means that whatever we enter first will come out first. So by this logic, 9 element should come first out, right? As the 9 was the first element to get enter. So 9 will come out first. So when we will dequeue, then the 9 element will be get deleted from the queue, right? So this is all about the queue. And now again, if we want to dequeue, then the 5 will come out, then 7, then 3, then 4, right? So I hope you understand the concept of queue and how it works, right? So now we will move ahead. So now we will discuss the operations of the queue. So these are the few operations which you have to keep in mind as we discussed earlier also, like enqueue, dequeue, init. So enqueue is this function is used for adding an element in the queue. Dequeue is a function used for removing the element. So init is a function by which we initialize the queue, means we initialize the size of the array and all. And the front is a term which is used to get the front data item from a queue, and the rear is used to get the last item from the queue. So these are the terms you have to remember while doing the custom implementation, right? So next we are going to discuss the type of queue. So basically the type, like four type of queues are there. First, simple queue. Second, priority. Third, circular. Fourth, the double-ended queue. So with the name simple queue, you can understand that simple queue is a normal queue which has the two end, the front end and the rear end. And from one end we insert the data that is known as the front end, that is known as the rear end. And from the end we like delete the data that is known as the like the front end. Okay. So this is a normal queue and it follows the FIFO. Now the second type of queue comes is like priority queue. So basically in priority queue, every element or node, so basically every element is known as a node. So that node has some like priority defined. Okay. So which has the lowest priority, so that element will come out first. So basically in simple queue there is no priority with the nodes or the element or the data, but in a priority queue every element, every data or every node has some like predefined priorities. So according to the priorities we will able to delete or remove that element. So element having the like having the low priority will come out first. So this is totally depend on the priority of the element which will come out first, right? So next type is like double-ended queue. So in a standard queue, a character is inserted at the back and deleted in the front. However, in double-ended queue, character can be inserted and deleted from both the front and the back of the queue, right? So as we have seen in the simple queue that we insert the data from one end and we delete the data from another end. But in double-ended queue, it is not necessary that we can insert the data from one end only. We can insert and we can delete from both the end. So these type of queue are known as double-ended queue. Now the fourth type is circular queue. So basically a circular queue is an improvement over the standard queue structure. So in a standard queue, when an element is deleted, the vacant space is not utilized, right? So let's say that in this diagram, if we delete this 9, then this space will be not utilized. It will remain empty, right? So in circular queue, the vacant space are reutilized. While inserting an element, when you reach the end of the array and you need to insert another element, you must insert that element at the beginning, given that the first element has been deleted and the space is vacant, right? So now let's say that you like deleted 9 and again you deleted 5, and now you are inserting the data from one end, right? And this array get like full packed. Now you can insert the data here in, right? So in the circular, it uses the vacant data also. It uses or utilize the vacant data also, the vacant space or the index also, right? So this is all about a circular queue, and these are the difference between them. So we use the different queue according to our requirement. All right. So now like we will move ahead, and then yeah, and now we will see how we can implement our own custom queue with a Java language. So for that you have to keep 4 to 5 things in mind. The first, that adding the element in the queue is known as enqueue, so that we are going to write our own custom method, and inside the enqueue function we are going to write our own logic by which we will insert the element in an array, and then like we are going to delete the element from the queue. So that logic we are going to write inside a dequeue function. So in queue, two things is important to store the variable, and the first is the front. And yeah, so here we will take the two variable, the front and the rear, right? So these are the four things we have to keep in mind. And yeah, and also like another one is the rear, and the rear is the tail of the array, and it will be focus to the first item was added, right? So these are the four things we have to keep in mind. First, the enqueue method, and the dequeue method, and the rear, and the front, right? So now, like let's move ahead and try to write our own custom like implementation of the queue with the Java language. So we will go to the Eclipse, and here already I have created one folder with the name queue. So here like basically I'm going to create one class with the name, let's say, queue demo. And we will take the queue as an array. So I will take so like before implementing, I will tell that here we are going to see the two example. First, to insert and to delete the element in a queue with the data type, with the data type of integer. That is the primitive data type. And the second example we will see by writing our own custom with the object. So here we will use the student object, in which it has the two properties, the name and the roll number, right? So these are the two like example we are going to see. So let's quickly implement, and let's see how we can write our own custom queue. So this is like very important to understand. So I believe in the first like in the first iteration you may feel difficult to understand, if like if you are like a fresher to the data structure. But I believe you have to do some like practice, then like you will feel like it is like very easy for you to understand, right? So first of all we have to declare one like array, and the array is of like integer data type, right? So second, I have so define one more variable for the size. Okay, so size will define the size of the array, and now also we will define one more, so which will contain the total element. So size will contain the size of the array. So total will contain the total element in the array. And the another like variable I will define, as I have already told, for the front. So front will define one end, and another element with the name rear. So rear will define one more end. So these are the like five yeah. So these are the five the, like variables I have defined here. So now let's create the constructor for this. Demo, and this is the default constructor. So inside the default constructor I will initialize with the size 50. So let's say the array has size 50, and the total element, I will say that in the starting the array is vacant. It means that no element is there, so that's why I kept the total size as 0 and the front as 0, and also the rear has 0. All right, so these are the variables I have defined, and now also I will define the array size. So here I will take the array size as 50, or simply we can define the size also with the name size, because already we have defined this size here. Yeah, so this is the default constructor I have defined. Now we are going to write the method for enqueue. Okay, so function for adding element. So in this we have to keep in mind the logic Okay, so let me write the method first. Enqueue. So it must take one element now. So now the logic you have to keep in mind. So for that, I will like to take you here. So here for enqueue operation, you have to first check if the enqueue is full. So always we have to check that if enqueue is full. If enqueue is full, then we will return one exception by saying that it is overflow, and then we will exit from our program. And if the queue is not full, then we will increment the rear pointer to point to the next empty space, because you know that from the rear only we are going to insert the data, right? So as we will insert the data, after that we have to increment the index of this rear, so that when the next time it will insert in that part, right? So after adding the element to the queue location where the rear is pointing, then we have to increment that by one, and then we have to return success. So this is the logic you have to implement inside your enqueue. So first, as the logic said, first we have to check if our queue is like full. So for that we have to check with this method is full. So it means that I have to write one more method for checking is full, so which I will do in some time. So if let's say that if my queue is full, then it should return false. If it is not full, then what it should do, it should increment the total, because the total content the number of element, right? So we can simply do total plus plus. So it will increment the total value. So first time if we insert, then it will come to 1. It means that only one element is there in the array. Now we have to insert this item in the index, right? So for that, so this is my array, and in the index you have to put rare, because in the rare we are inserting the data, and then you have to write equals to item. So this item will be stored in the array of index rare. So rare has the index 0. So in the 0 it will get inserted. And now we have to increment the rare, because we have inserted the rare data, and the rare should be get increment by 1, and then we have to return true. Okay, so I hope you understand this point why we are doing rare plus plus, because we have inserted one element. Now the rare should point to the next index, so that's why we are doing rare plus plus, and then we are returning. So now we have to implement first the is full method also. So public boolean is full. So how we can check that if our like queue is full or not? So for that already I have defined one size, right? Size variable. So we will see size equals to total. So total content the total element value, right? So if let's say that the size is 50, and now my total elements has become 50, it means that it matches the size, and it should means that it is full. So it should return true, right? Otherwise, if the size is not equals to total, then here it should return false. By this way we can check that our array is full or not, right? So total means total element, size means total size of the array which we defined earlier. So if total is 50, size is 50, then it means that our array is full. It will return true, and then here it will not. And if it is true, then it will come out, and it will not insert any element in the queue, right? Or here you can like return some like message also by putting it a string that your queue is full, something like that. Okay, so it's totally depend on you. So for now I'm just using for false and true, right? For like make you understand. Now we are going to implement the second method, that is dequeue. So dequeue is used for deleting the element from one end, right? This is dequeue, and it should return some item. So this should not be boolean. This should be integer type. So now, so what we have to do? So I will store. So means I will take the value or the element from the array. So from which index I have to take? As I have already told that in simple queue we have to delete the item from the front. So this is my array. So in the index part I will use the front variable, right? And now the front is 0, so it means that it will take the first element which is inserted, and then I have to make the total variable also decrease by 1, because here we are. So here from the array in the index of like front, it is storing to the item integer, and then we are decreasing our total with 1, and also we will increase with, and also we will increase the front with 1, right? If the front is this, then it will then we will increment with 1. So increment to the front is done so that it will point to the next item for dequeue. Okay, and the decrement of the total is done because one item has been deleted or removed, so also we need to decrease this total value, and then here we will return item, right? So by this way we will dequeue or like remove an element from the array, right? So this is the like functionality we have to write. So this is for enqueue for adding one element, this is dequeue for deleting an element. Now let's write one more main class for execution. Queue main, and here I will define one main method. So inside the main method, let's put some system.out.println main method. All right, queue demo, queue equals to new queue demo. Okay, and now I will insert some enqueue. So I will do enqueue, and here I will take the element, let's say first element as 3, and then I will insert more element here, 5, let's say 6. So these are the element I have entered in my queue, and now let's dequeue and check system.out.println. For this I will use queue dot, we can use the queue method, dequeue method. So this will delete the first, this will delete the second, this will delete the third element from the our queue. Okay, so let's save it. I believe, oh, I have to save this file. Now it's fine. Now let's run this class and let's check the output. So this is in the Java application. Hmm, let me check the console. Yeah, so here you can see in the console, first the main method ran, and after that we have enqueued 3, 5, 6, and when we are doing the dequeue, then the first element which we enter is also getting deleted, that is 3, and then after that 5, and after that 6. So it means that we are able to implement with the FIFO logic, first in first out, right? So this is all about the enqueue. And here I have shown you the example in which we are inserting an an element with the data type of integer, that is the primitive data type, right? So actually in the real like application, or in the enterprise application, we will see uh, means like we will work with the objects, right? So for that, what I will do, I will show you the another example in which we will enqueue and dequeue the object. So so here I will create one student model class. So there will be two properties, basically the name and the roll number, and then we will try to enqueue and dequeue. So for that, I will again create one separate class. uh, let's say student model something. So the student model has a name of string type and the roll number, right? So let's create the constructor for this. So I will create yeah, so name, string, roll number. Fine. So here we can call the super method also. So this dot name equals to name, this dot roll number equals to roll number, right? So this is about the student model. Now I will try to create one more like constructor, the default constructors. Let's create by this select all field. So this is my default constructor, and also put I will generate one to string method. So this is the to string method, right? So this is my like a student model object class in which we have the name and the roll number. So now I will create the class where I will write the functions for enqueue and dequeue. So student queue demo. So first I have to create the array of type student model, right? Private, it will be of student model array. So the name of the array will be q. Now I will define the other variables like size, as I have done in the previous example. Total, front, private integer, rear. So let's create our default constructor. Right? So this is the default constructor, or maybe I can define the default constructor with the size equals to 50. I will take. Then total I will keep initially as 0. It means that no element is there in the array, and the front as 0 and the rear as 0, right? So these are the initial like values of this property, and also I will define the size of our array. So student model and here I will define the size. So here the array is of size 50. All right. I Yeah. So I hope you understand this point. Now we are going to write a method for enqueue for inserting the data. So as we have done, first we need to check whether the queue is full or it is empty. So before that, here we need to pass the student model object which we need to save. So this is of student model type. Now I need to first check that if it is full. So is full. So for is full method, I am going to write the logic in some later part. So here if it is full, then simply return false, or any message which we can do according to your requirement. So inside else, if it is not full, then I need to increase the total size because now I will add one element. So I will increase the total value with one, and then I will store one element in the array of index rare. So storing this item in the index of rare in the array. Okay, I hope you understand this point. Now the next point is I need to do the rare plus plus. Means I need to increase this rare. Now it's fine. So rare plus plus. And then I need to return true also. Return true. Fine. So this is my logic inside the enqueue. So for if full, I will write in now, just now. Okay. So before that, let's write the another method for dequeue. Method for dequeue means for removing an element. So similar way, I need to return the student type class object. Dequeue. So student model item equals to, so from where, from the array of index front, from so we are going to take store that element which is in the index front. So we are going to store it in the item value. Okay. Now I will do total. So now I will decrease one value of total, and then I will increase the value of front because we are deleting. So we have to make or decrease the total as with -1, and also we have to make our front plus plus. So this increase we are doing so that it will point to the next item when we have to do the dequeue, and then we will return the item from here, right? So here spelling is wrong. Yeah, now it's fine. So this is the logic inside the dequeue. Now so now I will implement the is full. So public boolean is full method, and here if the size is equals to total, if the size is equals to total, then we have to return true, else we have to return false, right? So this is the logic inside is full method to check whether our array is full or what. So if our array is not full, then it will insert one element, and if it is full, then it will simply return false. So this is the logic we have to write here. So this is our like dequeue method, and here this is our enqueue method. So next I am going to write our like main method. So let's create one class with the name something student, student main. So inside the student main, I am going to write our main method. So first I will do some system.out.println. So student main. All right. So next I am going to create some student queue demo. So here I am going to create some student object. Yeah. So student model, student equals to new student model. And now I need to use the enqueue. So student model dot enqueue method. So inside the enqueue method, I'm going to insert some variables or the value. This is my model. Is it referring to that? Let me check once. Yeah, this is the student method. I have to save it. Enqueue. Enqueue. Uh, so here I need to create the object of my student queue demo class, right? So by mistake, I have created the object of my one model class. So student model. I believe now it's fine. So student model dot enqueue, and inside that I need to create again the object of my student model. So here I will do the student model, okay, and then I will pass the values. Let's say name of the student is this one and the roll number 456. All right. So I will insert one more element, Bhagat and 655. Now, so now I need to show all the element, right? So for that, what I will do, I will write one more method inside our student queue demo class. So here I'm going to write one more method which will fetch all the element from the array of queue, and then it will show. So this is show all method, integer f equals to front, okay, and then if total is not equals to 0, fine. If total is not equals to 0, so we are checking if total is not equals to 0, then what we are going to do, we are going to iterate. So we will put the for loop, integer I equals to 0, I is less than total, so it is going to iterate from the total, and then I plus plus. All right, and here I will put system.out.println plus q. This is the array, and here I need to put the index. So I will put here the f. So f is the front, right? So front dot to string, because f contained the object, so I should use the to string. So to string method is to return the information of the object, right? So by this way it will iterate the total element and then it will print. So we can call directly the show all method inside our main class to display all this. So student model dot show all method, right? So by calling this show all method, we can check all the elements. So let's save this and let's run this main method and let's check the output. So you will see in the output, the first element we inserted is Ashish and 456 and Bhagat 456, right? And when we are calling show all method, so first it is like first it is like deleting this element or taking out the element which is first inserted. So with the name Ashish, and then so I think there is some mistake because two times it is taking Ashish, right? So maybe I missed something in the logic. Let me check quickly. Oh yeah, I missed here one point because I have to like increase this f also, right? After taking out the value, I need to increase f equals to f plus 1, and then I will do size. Now it's fine. I believe it should show the output correctly. This is the main method. Yeah. So now you can see the first element we inserted with the name Asis, and the second object we inserted with the name Bhagat. And now when we are dequeuing, so first inserted will come first. So Asis is coming first, and then second is coming Bhagat, right? So in this way, you can write your own queue logic. So queue is basically the main point is that queue is basically a FIFO, follows the FIFO, first in, first out. So in the data structure, we have to implement our own custom implementation for the queue. So you have to keep the two things in mind. For enqueue, you have to check if the array is full. If it is full, then you have to simply return with the message. Otherwise, you have to increase the total size, total element also, and then you have to store that item or the element in an array with the index rear, and then you have to like increase that rear also by one. So in the same way, you have to dequeue, then you have to store the item from the array to the student, to the item, and then you have to decrease the total element and also increase the front, because for dequeue here we are using the front, and for enqueue, for inserting, we are using the rear, right? So these are the two end points of the array of the queue, right? So guys, I hope you understand how we can implement our own queue in the data structure with the Java language. Yeah. So guys, I hope you understand the concept of the queue and how it works and in which like principle it works and how we can implement this, right? So in the next lecture we are going to see about the linked list. So stay tuned and subscribe our X admin channel and also hit the like button. Thank you and have a nice day.